So, good morning, everyone. Welcome to today's session. So, today we'll be taking on conditional probability, naive-Bayes classifier, and see how what are its applications and how we can implement that in text mining and other applications as well. So, let us start for today. So, mainly here we work with the probability or conditional probability. Given that if there are some issues or some event has already happened, what is the probability of happening that event? So let's say, uh, uh, so let us understand what it is. So naive-Bayes classifier are family of simple probabilistic classifier based on applying Bayes theorem with strong independence assumption between the features. It is a popular method for text categorization. So text categorization is also a part of today's session. So we will see that how naive-Bayes classifiers are helpful in that, and that is classifying documents as belonging to one category or the other. So let's say if I'm receiving uh, a number of messages in every day, and how I can classify that if that message is a spam or uh, something that I require or something which will be useful. So that categorization can be done using naive-Bayes classifier, and it is mostly used for text mining and understanding that which category that text should belong to. So, and using word frequency as the features. So what happens is, so how much that word has occurred on basis of, for example, if a spam message you have received, so it will be like, congratulations, you have won so and so, uh, or something like, please reply on this number, or there will be a question that answer this question to win so and so money. So these are the main texts that occur in a spam message. On the other hand, if you are receiving a genuine message from your friend, so it will be a bit different. For example, the words will be direct, will be directly addressed to you. You will be asked to do something, or he will be saying that I will be reaching at so and so place in so and so time. So there will be a difference in text. So using that words frequency and the way the words are used, Naive-Bayes classifies the text in a spam or a genuine one. So with appropriate pre-processing, it is comparable to more advanced method. It also finds application in automatic medical diagnosis. So this is the simple formula that we have for conditional probability. Condition of outcome given that data. So first of all, condition probability of outcome given that data, and that will be equal to probability of data in that particular outcome and multiplied by total probability of that outcome, and this whole divided by the total probability of data. So at first glance it would seem a bit complex to understand that how it has been formulated and how we can comprehend this. So let me make it very easy to explain and understand that how it works with a very simple example. And the last note here is, since the denominator is same for all the possible values of the outcome, it is enough to evaluate the numerator for all possible values and then compare the likelihoods to determine the most likely outcome for a given set of observations or data. So let us take a very good example so that you all can comprehend that well. So this is the example that I have taken. So suppose there are two people who are traveling in a train, and we have a Raj. One person is Raj and another is Simran, and both are traveling in a train together. But for some reason, Raj is not able to figure out whether Simran is a male or a female. So he only knows that Simran has longer hair. He can only say that Simran has longer hair, and he is not able to figure out the gender. But good thing about Raj is he is good at mathematics. He know how to apply conditional probability and Bayes theorem. So he notices that uh, Simran is having longer hair, and on basis of that he is trying to predict the probability that what will be the gender of Simran. So let us understand how it works. Raj also notices that how many passengers are there in the train. So there are around 180 passengers, and out of them, how many males have longer hair and how many females have longer hair. So let us look at the situation. So there are 180 passengers in the train, 90 are males and 90 are female. 85 out of 90 females have longer hair, and 7 out of 90 male have long hair. So here is my table that I have put so far to make a better illustration of the situation. So people with longer hair, 7 are male and 85 are female, and total of 92 people have, or you can classify them as with longer hair. Shorter hair, male with 83, and female, only 5 female have shorter hair. So here is the total. So out of which, now if I make a conditional probability that being a female, oh, or having longer hair, what is the chance that that person would be a female? So for that, now I have made a knife base uh, formula. I've used the same formula which I have put in the first slide using this. So number probability of being a male is half. Female is again half. Longer hair is, as I said, out of total 92 by 180, and shorter hair 88 by 180. So here I don't say anything, but considering that for a condition that long and longer hair and that too of male is quite less likely, and longer hair that too of female is quite highly likely. So now my final condition becomes that the person will be a female having longer hair. The chances or the probability comes where somewhere around 90.38, and that too for a male with longer hair comes somewhere around 7.44. So in that case, Raj can comprehend or maybe come to a conclusion that Simran must be a female because she is having longer hair, or it is more likely for her to be a female. And based on this probability, he can classify. So this is an example how we can understand or how we can comprehend knife base, or we can use it in our daily life, or maybe in a practical situation, a more practical situation. So this was one example. Let me go to some other example and try to explain that how it will be if situation gets a bit more complex. So now here I have three categories of fruit. I have banana, I have orange, and I have other fruits. So this is in a different bucket altogether. And here I have some categories here also, that is that fruit long or short, long or not long, sweet or not sweet, yellow or not yellow. And I have a total then summation of all of this. So a summary kind of for all of them. And here I have summary for all. So total I have 1000 fruits, among which banana is 500, orange is 300, other fruits are 200, and same something similar for long or not long, sweet or not sweet, yellow or not yellow. So based on these conditions, I need to predict that what would be my fruit, whether it will be banana, it will be orange, or it will be other fruits. So here I have prior probabilities. So as you can see, banana was zero point 0.5. It was quite evident that out of 1000 we have 500 as banana. For orange, similarly, it would be zero point 0.3. For other fruits, it will be zero point 0.2. Now, probability for being that fruit long is zero point 0.5 again. Sweet is 0.65, and yellow is 0.98. And now we have a conditional probability. It means it is long given that banana. So here you can see long given that banana is 400 by 500. So that will be 0.8. Here I have long given that it is an orange, that is 0. So 0 out of 300, that will be 0 again. Oranges are never long in the fruit we have seen so far, so it is quite obvious. And yellow and other fruit. So let us see. Yellow, where it is yellow and other fruits. So it is 50 by 200. So again 0.25. So there we have formulated all the probability of likelihood. And now let us get to the formula that we have for knife base. So considering that what is the probability given that I, what is the probability of finding that fruit to be banana given that it is long, sweet and yellow. So for that I have my formula. Given that long it is banana, given that sweet it is banana, and given that yellow it is banana, and total probability of banana given by product of probability of long, sweet and yellow. So here what one thing here as well. So I have not calculated the P of evidence because anyway I have mentioned in the first slide that denominator will be almost the same for most of them. So if we can just compare the numerator, we can get to the conclusion. So now here if you can see by an overwhelming margin, you can see that. So for uh, let's come to orange, it is 0, and for other fruits I can see 0.01875 by P of evidence. That is my denominator. So here if you see by an overwhelming margin 0.252 is much greater than 0.0875, and we can classify that if given these three conditions, sweet, long and yellow, the fruit is more likely to be a banana compared to other two categories. So this is a simple illustration of naive Bayes or conditional probability, how it works and how we can use it, and how we can use it in text mining. We will see some of the case studies that we have. So any confusion, any doubt till now, let me know. So before I proceed, fine, okay. Okay then, so let's get to a real life situation and understand. So I have taken this iris dataset and I need my naive Bayes classifier to work on this and to predict what kind of flower it will be. So let us look at the iris dataset and try to understand what is there. So here I have simple length, width, petal length and width, and based on this I have my species. So based on these four parameters, I need to understand that what will be my species. And here I will try to work with my knife based classifier. So earlier day, if you remember, we have taken the same data set in KNN for weighted distance KNN calculation. And there we got only one misclassification and rest all were correctly classified. So today we will work with the same data set and we will try to understand that how knife base will work on this data set. So here as we have seen first six observation, that is by default for head, we have simple length, width, as I said earlier. So let us now straight away do one thing, divide our data set in train and test, and we will train our model on knife base and then we will test it on the test data set and try to understand. So I have set seed 1 2 3 4. It is a random number, so you can choose it of your own as well. Any random number will do, so no issues with that. And again, using this random sample that is generated, I will segregate my data in train and test. Now I will store my naive base of species with all the variables that I have. Species will be that naive base classifier will run on all of them. So okay, could not find the function. So I need to install that library before I proceed. Okay. So here let me run this naive base classifier. Now it has executed. So here I have for conditional probabilities for all of these for simple length, favor, and in odd what will be the length. Okay. So on the basis of this, let us try to predict on the same trained data set, not on test. In the same trained data set, and let us try to see what is the result that we are getting. So here if I can see, Setosa has been classified 100% accuracy, Verisocolor with some inaccuracy. I think few of them has been misclassified. So and here Virginica also mostly correctly classified, but so yeah, here it was 100% should have been here, but all the misclassification goes here in Virginica. Verisocolor, this part that is missing goes here, and Virginica, what is missing comes here. So a bit of misclassification in the trained dataset. Let us work on the test part and try to see if a out of bag sample comes in, then how this model will work. So not bad. Let's say even a good, quite good results that we have got. This is predicted. So here with 100% accuracy we have predicted. Here also 100% accuracy we have predicted. Also here the prediction goes down. Only for few cases we can conclude that it hasn't been correctly classified, but overall it looks good. So if I execute only TQ, so here only one misclassification, which is fair enough, not bad at all. So in a way it has been quite good. So let us take one more example. This will be of raw text and how naive Bayes is used in text mining. So we will see that. So here I am taking some of the positive and negative reviews that I have. So on basis of that, I will try to make a classification. So let us work with that data. So where I have it. So let me see what is there in my data set. So here I have text and here I have as classification, whether it is a positive review or a negative review. So let us try to read a comic like From Hell before started. It was created by Alan Moore and Adi Campbell. So a big text that has been provided on a big review. So let us not go through it. So quite a big review for each one of them. I can see it is quite huge and enormous. So and all of them are positive. And there are few negative, but I think all the positive are in the upper half and negative are in the lower half. So let us see how it has been, how the distribution of classification is. df class. So 1000 negative and 1000 positive. So both equally distributed, but only problem is that first comes my positive, and after that, after 1000, I would say observation, my next 1000 negative observation comes. So what I need to do is I need to put them all together randomly placed, so that there is no bias when I sample out my train and test data set. So I need to mix them up properly. So let us do that. I've set seed as 1, and now I will randomly sample all my data set and put them back to df. Now if I see negative, positive, negative, 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 and it has been randomly placed. So now if I look at my df, so now see it has been randomly placed, and also the row number it is providing me. So 190 1914th row has come at the top, and now it looks a bit random. So positive, positive, negative. So my work has been done. So let us proceed. I have made this class as factor, so that I know that I have only two levels, either it is positive or a negative. So I will make a corpus of all my text. So corpus is mainly making a document of all my text. So in R, what happens is this is a normal text, and making it into a corpus will signify R that it is a type of document, and I need to treat that as a document, and that will be better when I am treating, or when I am working with text mining package. So for that, let us convert that into corpus, and let us inspect that corpus. So corpus here I have around 2000 documents, and within this 2000 documents we will try to explore. So corpus 1 to 3, first the corpus if I am checking. So the review was quite huge, so it has truncated itself. No issues. So
Yeah, Ankit,
yeah, yeah, Shashi, tell me.
can you explain the corpus again? Yeah,
Okay,
can you again the corpus function,
okay,
what it is used?
okay. So here let me. So corpus mainly comes in the text mining package. So what happens is when I'm working with a large number of uh, documents or the text, so this is a good way to actually put them together in a document and then to process it. So here there are later on we will be working on more text mining functions, for which converting into a corpus will be required. So naturally what it does, it converts it into a document, and from that document we start working with it. We start cleaning that document, ignore all the punctuation mark, special character, convert all of them into lower, and then work with it. So if you understand what is written here, are the collection of documents containing natural language text in package which employ the infrastructure providing by package DM. So this is mainly the purpose of corpus, to just to make it into a document, and from there we will convert it into a matrix where we will be having a document term frequency. So mainly it is in just simple terms, if I would explain, it is mainly to put it into a document.
Okay,
So here I'm using a dip layers pipelining method, and here what I will do is I will clean my corpus. So here I will take my corpus, I will transform all the characters into lower, remove all the punctuation marks, remove all the numbers, remove all these stop words. So in English, stop words like adjectives, like has, it has been, is, was. So these are the kind of stop words that are used. So we will be removing that stop words, cleaning our document, and white strip white space. White space will be two consecutive blank that will be removed. So let us do that and clean our text. And now I will be converting that into a document term matrix. So what is it? I will explain a bit, but let me first run this, and then I will explain that what happens in DTM. So in DTM, if I, let's say if I view this DTM, okay, it cannot be. So I think first I have to convert it into a matrix and then it will work. Okay, so acha, start. Okay, quite high size. So okay, let us inspect only. So here if you can see, I have subsetted the document. I have taken only from row number 40 to 50. And here what happens is, in the column I have all the words apparent, assured, audience, back, bacteria, bear, and so on. And what it is trying to convey me is that what is the frequency of that word used in that document. So document number 40 has audience, appearances of audience one time, back one time. Here in document number 44, I have back one time and audience here twice, and then audience here twice. So mainly, I think it should be for a movie and or something which addresses the audience. So that's why the word or frequency of audience is quite high. So this is mainly what was there in the corpus, or what actually was there in the document. I have first cleaned it and then I have made a matrix of it. I have taken all the, I would say, words as my column, and I have flagged it, or I have counted the frequency for each document. How much is the frequency? And if I look at the dimension, so let me see if that will work or not. Uh, so see, here I have 2000 rows, and my number of columns have gone up to somewhere around 39,000. So just look at the difference. So previously in the corpus I was having only one column, and now I am having around 39,000 columns. So many words, and each of the words have been flagged or have been mentioned that whether how much is the frequency of that word. So now as I have done this part of document term matrix, I have flagged for all of the words that I have. Now let us divide our data set into train and test. So here 75%, or from 1 to 1500, I will be taking in the train and rest in test. And let me see that how it goes. So this is the raw data frame, the initial data frame that I had, that has been segregated. And now I will work with DTM. Same segregation for DTM as well, and same segregation for corpus as well. So DTM train, here I have 1500 and same number of columns that I had. So now here I'm making some transformation. What I'm doing is I'm keeping only words which has frequency minimum of 5. Anything with below that I'm removing that. So what the idea here is that If a word is less frequent or has occurred only once, twice, or thrice, or maybe even four times, then I don't think that that word is much big use, because I have some 1500 rows of observation, and in that, if a word has occurred only such less time, then I don't think that word is even uh, significant at all, so I should ignore those words. So that is the idea. So anything below 5, I will be ignoring that. So now if I say from 38,000 words it has reduced down to 12,000. So see, so many words were of no use. It was actually of redundant actually. So removing this, I have reduced my data set to such a good extent, and it will be easier to work with lesser number of words. So let us now modify our document term matrix, or DTM, and include only words which are there in our frequency or our dictionary. 5 frequent words, more than 5 or equal to that. So we will take only that, and let us see what comes. So here we have 1500 and number of columns is 12,144. Same thing I will do with test data set. NB I have mentioned here because I want to do knife based classification on this, and for that reason I have mentioned it NB. Mm, okay, this should be test. So 500, 12,000. So good going so far. Now here in the next step, I'm making some transformation. I have called a function. What it will do is, so here if you can see, uh, the word audience has somewhere occurrence of once, somewhere twice, so on. So what I will do is, I will flag them. If the count is greater than 0, then 1, always 1. Otherwise it will be 0. So it will be in binary, either 1 or 0. So this 2 will become 1, 2 will become 1 will remain as 1. So anything equal to 1 or greater than 1 will remain 1, and 0 will remain 0. So this is what this function will do. Now I will convert that for my knife base that I have just made into uh, 1 and 0. It will take a bit of time. So now let us make a classification on the spaces, or my knife base. Executed. And now let me try to predict it on test and how it goes. Okay, so it has executed. So let us try to predict that how it has worked. So here if you can see, these are my actuals and these are my predicted. So here uh, these many have been predicted correctly. Or what I do is I put it in a table, and here I take it text. So it will be easy to understand that how much is my percentage accuracy. So I've rounded it off onto two decimal places, and one means that aggregation will be on the basis of row. So here I have negative correctly classified as negative 80% and positive correctly classified as positive as 81%. There are few misclassifications as well, but with this model I am able to some extent I am able to predict it well, that how much is my negative and how much is my positive. So in a way, as I can conclude that it has performed it well. Also, I can fine tune it to further extent. uh, I can select the word frequency, or maybe what I can do is I can set the high word frequency to some other value. So here, if you see, here I have low frequency. I have set that equal to 5. What I can do is I can set my high frequency to also a certain value, so that anything uh, above that will be ignored. So this is also a tuning method or a precautionary measure that I can make to ensure that my model performs better, so that things can be done. So in a way, a good model and a good prediction that I have done. So let us try to make a confusion matrix, and so here I have all the features of confusion matrix. Uh, it shows the same thing: how many correctly classified, how many incorrectly, n- negative as negative, positive as positive, and few misclassification. Uh, an amount of accuracy and my confidence interval of how much accuracy it can provide. So, uh, in worst case scenario, if I taking with a 95% accuracy, confidence interval of 95%, it could go down to 77% and it can go high to 84%. So, which is a stable one. Other features are also there. So, in a way, I can say a good prediction. So these are of all the sensitivity, specificity, overall all the values, and overall accuracy is 81%. So in a way of fine prediction. So let us try to build the word cloud for this and try to understand what was there in all the documents or the bag of words. So here I have considered only for train, not for entire one. Or let us do one thing. Let us check for entire and then we will check for train as well. Before that, let me do this. So I think it will take a bit of time. Okay, so this is it. So this is my word cloud. Let me zoom in. So these are all the bag of words that I have. So here I've made some restriction that minimum frequency of that word should be 40 and maximum number of words that I want in my word cloud to be 300, not more than that. And random order should be false. So the larger one should be at the center or the most frequently occurring words, and less frequently towards the edge. And I have set the colors parameter as well to dark. So this is my word cloud that I have. So as I said earlier, this sentiment was more about movies and film. So what I could have done is I could have removed this word film, movie, stories, because these are expected to occur quite frequently, and it has occurred quite frequently. So uh, this could have been a precautionary measure that I could have taken before running this model anyway. And also when you look at the word, so it is actually tells me that what kind of words or bag of words that I have had, and what people are talking about more, about director, about comedy, or black guy actually action script. So since doesn't this should have been removed as well, but it hasn't been spotted by stop words because this seems like a typo. Doesn't actually the word is or spelling is bit different and it is a spelling mistake. Uh, for maybe for that reason it hasn't, or could be possible because we have removed the punctuation mark and in that apostrophe has been omitted out. That could be the reason. So this is all the bag of words that we have. So let us do it for uh, other subsets as well. What I have done here is I have subset my data into positive and negative, and let us now try to understand that if I have a positive sentiment, then how my word cloud should look like, and if I have a negative sentiment, then how my word cloud should look like. So let me partition my uh, plot area to mf row equal to combination of. So let me do it this way: two columns and one row. So one row and two column. So all the positive going here and all negative going here. Now I have partitioned it. Okay. So let us zoom in and try to understand. So here I have my bag of uh, positive words and a bag of negative words. So if it is talking about something positive, it is saying about performance, real dawn, war, characters, and if it is a negative, I think actors have doesn't work well, or series, or uh, director again a similar bag of words, but in a negative way. So even one common thing that film and movie are the most commonly occurring words here, and it has occurred here quite frequently in both of them as well. So this was a comparative study for both positive and negative words, and also how knife base is used to classify my bag of words, whether it is positive or negative. So again, a good technique to understand and classify. So this was all I had for today. So any doubts, you can tell me, or we are good to close. Okay, so let
Yeah.
me explain. So text mining is here. I remember uh, text mining is mainly for cleaning of data that we have done, and also uh, data transformation. So these are all the things that we have done through TM, and the code that is there for TM, this TM app. So transformation into lower punctuation, these are all done through TM app or TM package, and also conversion to corpus. This is also done through TM. So this is where my TM comes into picture. Second is my this. So our text tools, I have to check that whether I have used it or if I have at all used it or not. So this is used for A1071 is for naive bias. So the naive bias classification that I have just done, or the uh, algorithm that I have used here, you can see naive bias, that comes in this package. So if you don't load this package, this won't work. Dplyr here I've mainly used for pipelining. Pipelining, I think I have done it yeah, here. Here I've done the pipelining. So for this, dplyr was used. Apart from that, I don't think dplyr was used anywhere else. Uh, Also, and carrot was, I think carrot for some other purpose. Yeah, carrot I remember now. Carrot is used for this, where it's confusion matrix. For confusion matrix, carrot is used. And this are text tools. I have to say where I've used it or if it has been used at all or not. So let me check that our text tool and what all are. So thanks everyone for joining in. Thank you so much for all your constant questioning and feedback. Next Saturday we will start with the next topic. Till then, bye bye. Have a good week.